Okay, now I want to record number 3. Number 3 says that you have a car that has a mass of 1,300 kilograms. And this car is initially moving at 20 meters per second. I'm sorry, that's 20.0, so let's make that look like it should. 20.0 meters per second. And we want it to stop, so VF is going to go to 0. And we want this to happen in 80 meters. And we want to know what is the stopping force. Well, the net force is the stopping force, and it's equal to MA. But I don't have A, and I know that VF squared equals VI squared plus 2AD. So I need to write my equation. So my A is going to be VF squared minus VI squared over 2D. VF is 0. VI is 20. 2 and D is 80.0. So I got my acceleration when I solved that. And my value for my acceleration was negative 2.5 meters per second squared. So now I want to go over and do my net force. My mass is 1,300 kilograms. My acceleration is negative 2.5. So when I multiply those together, my net force is negative 3,250 newtons. And you've got to have that negative sign to show that it is a retarding force. Okay, number 4 has a sports car. Mass is 500 kilograms. And it's heading directly for a railroad crossing 250 meters away. And puts the brake on because they see that the train is not through the clearing yet. So the initial speed of the car was 40 meters per second. And the braking force was 1,200 newtons. So part A wants to know what is the car's speed when it gets to the clearing. And then we need to find out if he's going to survive. So we're looking at the time. So first thing I have to do is I have to find the acceleration. So net F equals MA. Please show your equations. So the net force is the braking force. So negative 1,200 newtons is equal to the mass of 500 kilograms times some acceleration that is negative in nature. So the acceleration, when I did that, I got a negative 2.4, I think it was. Yes, negative 2.4 meters per second squared. So then VF squared equals VI squared plus 2AD. VI was 40 squared plus 2 times negative 2.4. And he has 250 meters to stop in. So by the time he gets to the railroad crossing, he is traveling at 20 meters per second. So that's what they were asking me for. And then they said it takes the train 8 seconds to clear the crossing. And so I need to find out how long it takes the car to clear the crossing and then compare those times. So I said, well, VF is equal to VI plus AT. That rearranges as T is equal to VF minus VI over A. VF is 20. VI was 40. And my A was negative 2.40 meters per second squared. So I had negative 20 on the top divided by negative 2.4 meters per second squared on the bottom, and I got the time to be 8 1/3 seconds. So the train is out of the way in 8 seconds. He gets there in 8 1/3 seconds, so he is safe by 1/3 of a second. Way too close for me. Not something I would do. Alright, so let's look at the next one. The next one is a 1,580 kilogram car, so I think I'm on number 5. The mass is 1,580 kilograms. Is traveling with a speed of 15 meters per second, so I'm going to make that be my initial. What is the magnitude of the net force that is going to bring the car to a stop in 50 meters? So VF is going to go to 0. And I have 50 meters to accomplish this. So I need the acceleration. And then once I have the acceleration, I can get the net force. So I have VF squared equals VI squared plus 2AD. So my A is going to be VF squared minus VI squared over 2D. So I have 0 meters per second because it's coming to a stop, minus 15 meters per second over 2 times 50 meters. So my acceleration is going to be a negative value because I'm slowing it down. And when I did that, I got a negative 2.25 meters per second squared. But they wanted to know the net force. Net F is equal to the M, which is 1,580 kilograms. Acceleration is negative 2.25. So my net F is equal to a negative, and when I did that I got a negative 35.55. But paying attention to my sig digs, my net force is going to be a negative 3,560 newtons. Going to put this one up and then we'll go to the next one.